we see about black body and black body radiation. Okay, so what is meant by black body? So what is mean by black body means? So according to Max Planck, so it was first defined by Max Planck. So the black body is a perfect emitter and absorber. A perfect emitter and absorber of all types of radiations. A perfect absorber and emitter of all types of radiation is called black body. So really, is there any compound which absorbs and releases all types of radiation? Means no. There is no possibility of presence of such type of compound. So what is mean by, but then what is the purpose to create the black body means? It is only an imaginary one. It is only an imaginary one. If a compound or nothing but a substance, a species absorbs and emits all types of radiations, that is known as black body. In nature, there is no such black body is present. There is no existence of such black body. For example, for black body, we can write a similar example, not 100%, which is equal to the black body. The hollow sphere coated inside with the platinum black material is the sphere is totally coated inside with platinum black, having a small hole on its surface. Then the inside part works as near to black body. It is also not 100% black body. It works as near to black body. Generally, any substance cannot release all types of radiation and absorb all type of radiations. For example, if you take an iron rod, so iron rod తీసుకుని heat చేద్దాం. On heating iron rod, at first on heating to this iron rod, so at first it become just pale red color, and still on overheating it becomes deep red color. On further heating it becomes white, and on more heating at last it becomes blue. Means there is a releasing of different type of radiations. Okay, not all types of radiations. Here we got red, white, blue. Red, blue, two type of radiations are released on heating of iron. If a body emits or absorbs all type of radiations, that will be treated as a black body. In nature, there is no such compound exist which works as a perfect black body. But we have an example that a hollow sphere coated inside with platinum black, having a hole on its surface, then the inner part works as black body. If you heated any black body, if this black body is heated, just we are taking like this. If the black body is heated, it releases some radiations. So not only black body, any body. Any body on heating releases radiations. So here on heating the black body, it releases some radiations. On heating to the black body, the emitted radiations are called black body radiations. The emitted radiations from the black body on heating it is called nothing but or called black body radiations. Now we study this about black body radiations according to Max Planck. So Max Planck given a perfect explanation by on his concrete observations on this black body radiations, and he given a theory called Max-Planck's quantum theory. Next we see the main observations done by the Max Planck on these black body radiations. Okay. See the Max Planck's observations. On heating the black body, the released black body radiations are observed by the Max Planck and given some conclusions that on y-axis taking intensity, this is wavelength. By observing these radiations, he got that this type of curve, this type of graph. So here at last the lambda is highest one. Last position means lambda is highest one. So normal here 0 means the lambda is very nothing but 0. Here height increases means intensity increases. Means the height indicates the intensity. This length indicates the wavelength. Okay. So here at first we come from back side. Here it is a larger wavelength present at this point. And what is the height of this graph at this point? No height. Means there is no intensity is present. As lambda decreases, we are coming to the back side. Lambda decreases. As lambda decreases, height increases. So lambda increases, this height increases means height indicates about the intensity. So as lambda decreases, its intensity increases to a maximum. After reaching a maximum value, again further decreasing of wavelength, there is again decrease in the intensity takes place. There is no perfect connection between the intensity and lambda. You can't say directly proportional or inversely proportional. So at first the higher wavelengths the value is least for intensity. As the wavelength decreases, the intensity increases to a certain level. Then on further decreasing the lambda value, it is decreased. So for example, we are taking this experiment at T1 temperature, and he observed that on heating to the black body at more temperature. So this is the observations in the form of graph on heating to the black body at a T1 temperature. Next, on heating to the black body at more temperature than T1, he observed same type of curve with some differences. He observed same type of curve. Same type of curve means here also at higher wavelength intensity is less. As wavelength decreases, its intensity increases to a maximum. Then further decrease in the wavelength, it will decrease. Means the variation is same, but the highest point, nothing but the peak, the highest intensity obtained at lower wavelengths. So అంటే ఇక్కడ ఫస్ట్ T1 temperature, this is take at T2 temperature. సో T1 temperature ఎక్స్పెరిమెంట్ చేసినప్పుడు ఈ గ్రాఫ్ ఈ షేప్ లో ఉంది, కాబట్టి ఇక్కడ మాక్సిమం వాల్యూ ఎక్కడ వచ్చింది, ఇంటెన్సిటీ 10 యూనిట్స్ అనుకుందాం. అదే on increasing the more temperature, on heating to the more temperature to the black body, same type of curve, variation same ఉంది. సో కానీ ఇక్కడ maximum highest point ఎక్కడ వచ్చింది, మోర్ ఇంటెన్సిటీ. ఒక 10 యూనిట్స్ చూసి ఇక్కడ 15 or 20 యూనిట్స్ దగ్గర ఇంటెన్సిటీ వచ్చింది. And important one means the peak value shifted, the highest value shifted to the lower wavelength. Okay, intensity is increased, the maximum value reached at lower wavelength. Like ఇక్కడ ఈ పాయింట్ లెఫ్ట్ హ్యాండ్ షిఫ్ట్ అయింది మీన్స్ lower wavelength shift అయింది. Okay. So these are the observations done by the Max.Planck on black body radiations. So now we read the main points. On decreasing wavelength, intensity increases to a maximum value, then decreases, and then goes on decreasing the lambda value, the intensity value increases to a maximum, then decreases. Next, as temperature increases, maximum intensity obtained at lower wavelength. Means what will be the relation between T2 and T1 means the T2 is somewhat greater than T1. Okay. As temperature increases, అంటే ఇక్కడ బ్లాక్ బాడీని ఫస్ట్ T1 ఈ టెంపరేచర్ హీట్ చేసి దానికంటే కొంచెం ఎక్కువ హీట్ చేస్తే increases, maximum intensity obtained, this maximum peak is obtained at lower wavelengths. అంటే ఇంకా ఎక్కువ లాంబ్డా డిక్రీజ్ చేసిన తర్వాత there is a getting of maximum intensity value. okay, at lower wavelengths. Okay, these are the observations given by the Max Planck on his black body radiations experiment. So on these experiments and observations, he was able to give a theory called Max Planck's quantum theory. Now we see the main points in the Max Planck's quantum theory. So Max Planck's quantum theory. So again to Max Planck's quantum theory, the behavior, nothing but the nature of black body radiations is the electromagnetic radiations any electromagnetic radiations are associated with a definite amount of energy that is called radiant energy. So the electromagnetic radiation, so any type of radiations associated with a definite amount of energy is called radiant energy. And here main important one, this radiant energy is emitted or absorbed. We know that any compound on heating it emitted some radiations, and on falling another choice is on falling light on that substance, it is able to absorb some light, nothing but absorb some radiations. So whatever it is, absorb or emit, that radiation energy emitted or absorbed, whatever it is, the radiant energy emitted or absorbed is always in the form of always in the form of discontinuous manner. Discontinuous manner means energy is not released in the form of continuous manner, and energy continues to releasable. There is no releasing of energy in continuous manner. By observing that graph, he was able to give this point that the radiant energy emitted or absorbed by the black body is always in the form of discontinuous manner. Okay, a discontinuous manner long. Okay. So what is the discontinuous manner? he given that the emitted or absorbed energy always in the form of small packets. The released or absorbed energy, radiant energy, is in the form of a small packets, or nothing but a bundle of packets. In the form of small packets, the small packets are called quanta. Means what are the quanta means? They call energy packets. We know that they are having definite amount of energy in the form of small packets. The bundle of small packets. The small packets are given as quanta. Means quanta means it is an energy packet. It indicates about energy. And every quanta consists of energy. Every quanta is consist of definite amount of energy. A definite amount of energy. The quanta means the small packets of energy. The quanta is compulsory consist of a definite amount of energy. Now there is some points are given for this quanta's energy. The energy of the radiations, emitted or absorbed are always directly proportional to their frequency, E proportional to nu, and E is equal h nu. Here h is called, E means energy, we know that, nu frequency of that light, nothing but radiation. The h is Planck's constant. So what is the Planck's constant value? That is given as 6.625 into 10 power minus 34 joule into second. Or in terms of ergs, that is 6.625 into 10 to the power of minus 27 erg into second. So this is in SI method. This is in CGS method. Now we can write 1 joule is equal to 10 to the power of 7 ergs. So E is equal to h nu. So the relation to the E1 and h nu is equal to, or we can write equal to h. In the place of nu we can write C by lambda, or E is equal to hc by lambda. In the place of 1 by lambda means we can write nu bar, that is EHC nu bar. EHC nu bar. In the problems we need some relations. By taking this equation we can write E is proportional to nu means E1 by E2 is equal to nu 1 by nu 2. Just comparing their energies and frequencies. Next, E2 lambda. E1 by E2 is equal to, lambda is inversely proportional. That is lambda 2 by lambda 1. Next, relation between E and nu bar. Exactly with nu. E1 by E2 is equal to directly proportional means nu1 bar by nu2 bar. Here we have H is Planck constant, C is speed of light. Speed of light. So we know the value of speed of light. Centimeter per second or 3.0 into 10 to the power of 8 meters per second. Okay, these relations are mainly useful in the calculations. Next, some more points in the Max.Planck quantum theory. So we already said that the emitted or observed radiations consist of energy, and the energy not in the form of continuous manner. It is always in the form of discontinuous manner. The discontinuous manner means that is in the form of small packets. The small energy packets are given as quanta. The quanta means that is by the form of energy which is having a definite amount of energy. And also given that the energy of quanta is E is equal to nh nu. Here n is equal to 1, 2, 3. Any positive integer means the energy of quanta is always in the form of always in the units of h nu or 2h nu or 3h nu like that. Here n should be in a positive integer. There is no fractions in this energy. Next, the quanta packets in light, the energy packets are called energy particles. That energy particles in the light are known as photons. Photons means they are energy particles of light. The energy particles of light are called photons. Already we discussed about the intensity. Intensity means it is directly proportional to number of photons. Like light lo manaku general there is some lights are having with high focus. So ఎక్కువ ఫోకస్ ఉందంటే మీనింగ్ ఏంటంటే there is the number of photons are highest. అదే మనకు లైటింగ్ కొంచెం ఫోకస్ తక్కువ ఉంది మీన్స్ the number of photons are less. Means the energy particles of light are called photons. And next there is one important one, the quantas. Nothing but energy packet released from a black body or any other substance moves in the form of wave. The energy packets are moves after releasing, they move in the form of wave. They move in the form of wave till they are absorbed by any substance. ఏదో ఒక సబ్స్టెన్స్ అబ్జర్వ్ చేసేదాకా దే మూవ్స్ ఇన్ ద ఫార్మ్ ఆఫ్ వేవ్. సో ఫర్ ఎగ్జాంపుల్ ఎక్స్ అనే సబ్స్టెన్స్ అబ్జర్వింగ్ దిస్ క్వాంటా. In that X substance, if electron is present in lower level, by absorbing that radiation, the electron is excited to higher level. If an electron present in the lower level and it absorbs the energy of that quanta, it is excited to its higher level. So it indicates that the quantas are having some amount of energy. So these are the main postulates about Max-Planck's quantum theory, which well explains the black body radiations. Then afterwards it is applied to nothing but it was converted to all types of radiations. At first he given only to explain about the black body radiations. So afterwards it was extended to explain all type of radiations. Okay.